In lecture 4 of our selected topics in decision modeling, we shall continue the investment problem which we have taken up in our previous lecture, and after that we take another project allocation problem and see how this investment problem and the project allocation problem has got a similar structure. So, in our previous class we have taken up this investment problem. Very quickly, if we just reiterate, a company has rupees 5 lakhs to invest in multiples of rupees 1 lakh. If xj rupees are invested in investment j, then net present value of Vj xj is obtained, which are given by these three equations. And to know that if we invest nothing at a given stage or given investment options, then there is no NPV. That time the formula should not be used. The question is therefore, how should the company invest that rupees 5 lakhs in multiples of rupees 1 lakh so as to maximize the net present value obtained from all the investments. What we did, if you recall, we had actually constructed the following graphical representation, and these graphical representations really combine the stages. There are 3 stages. At every stage, the state is determined by the fund that is available for rest of the investment options. In the beginning, the entire 5 lakhs is available. After stage 1, it could be either 0, 1, 2, 3, 4 or 5 depending on how much you have invested, and at stage 3 also, that is 0, 1, 2, 3, 4, 5, but finally obviously we have nothing left if we invested rest of the thing in the 3 investment options. And the decision was that x1, x2, x3, which are the amount invested in a particular investment option. What we said further, that there has to be a recursive relationship which we shall use, which that relationship should help us in solving the problem. It should not be just equal to a brute search or an exhaustive search method, which will really examine all possible paths of this plot. See, this is still a simple problem. So, for such a simple problem, you can still do an exhaustive search and you can find the solution. But think of not 3 stages, but 30 stages, and think of not just 3 options, but 30 options, and you can imagine how complex the graph could be. So, in such a complex graph, obviously we must need method which could be an exact method, but at the same time finds the solution quickly by less number of iterations. That is the essential part, and in order to do that we need to use a recursive relationship which from the Bellman's principle, which basically says Fn star Sn is the maximum value for a given xn value Vn xn plus f star n plus 1 Sn minus xn, where Fn is the stage n, f n plus 1 relates to the stage n plus 1, and these are the different values which I already explained in our previous lecture. So, how do we iterate? What we do, we start with the stage 3 calculations. So, at the stage 3, if you really look, the stage 3, the F3 S3, that is the investment that you do will be Vn xn equal to 4 xn plus 6, because that is the guiding formula, which is equal to n equal to 3 for n equal to 3. It is written twice. Now, at stage S3, at this stage, you have 1, 2, 3, 4, 5, 6 investment options. Obviously, at stage 3, one may not like to make use of these investment options. One may say that whatever remaining we might spend, that is what has come out also and as the optimal. But let us say, if we say for the sake of thing that if we really go for it. Now, at this stage one can have one of the 6 situations, that is either we have the fund that is available, it could be 0, it could be 1, it could be 2, 3, 4 or 5, one of these. But if you spend only 0 out of that, and if 0 is available, then the return should be 0. Look here, these are the option 3 values 0, 10, 14, 18, 22 and 26. So, 0, 10, 14, 18, 22 and 26 similar values are there. Now, if we invest nothing, then irrespective of whatever fund was available, if you invest nothing, you should get 0. That is the first column. Second column, if you invest only 1, based on the formula, your return should be 10, irrespective of whatever was the amount that was available, because unless you invest, you are not going to get return. So, if you invest 1, these are going to be your returns. If you invest 2, your returns will be 14, 14, 14, 14. If you invest 3, your returns will be 18, 18, 18. If you invest 4, it will be 22, and if you invest 5, it will be 26. So, having these kind of calculations, what we can get at the next stage, therefore, that what is the optimal value out of these. So, although all values are same, so obviously the first value I have taken, that is the 0, 1, 2, 3, 4 or 5, that is the optimal, and the values are 0, 10, 14, 18, 22 and 26. So, at stage 3 things are very easy to really compute, we do not have to do too much thinking, and let us go over to the second stage. See, here things are not as simple as you can see. So, we have to continuously refer to the optimal value of at the third stage. See, the optimal values are 0 to 0, 1, 10, 2, 14, 3, 18, 4, 22 and 5, 26. Those are the x3 star and the payoff at the third stage. Fortunately for us, these values are available here, right. These values are incidentally available here, because at the second stage if you invest nothing, then whatever profits you should get, those profits are actually guided by whatever profits you have got at the previous stage, right. So, those values are only going to be coming up and not the contribution of the second stage. So, in order to understand this, let us look at the recursive relationship once again. The payoff at a given stage is equal to the payoff at the previous stage plus the return which accumulates from this stage, right. So, this is the optimal payoff from the previous stage, this is the optimal payoff from this stage, and this is the contribution of this stage. So, or even these other equation anyhow, where we wrote this thing just quickly. This value at a given stage is equal to the investment at this stage and the optimal from the previous stage. So, having known that, now let's come to the specific discussions that we are doing, that is we are at the stage 2 of the calculations. So, at this stage, what we really find, this formula that V n x n is really 3 x 2 plus 8 plus f 3 star s 2 minus x 2, which is the optimal from the previous stage where n equal to 2. So, these are the stage 2 calculations. Now, you see, if you invest nothing, then whatever profits, because this portion will be 0, then only the optimal portion from the previous stage will be remaining. What is S 2 minus x 2? That is the remaining money. So, remaining money, if there is 0, then remaining money is 0. If x 2 equal to 0, if S 2 is 1, that means remaining money was 1. That 1 must have been spent at the third stage. See, this is the backward different what you call dynamic programming. At stage 3 you have spent say certain amount, the remaining amount you spend at the second stage. So, at second stage if you spend nothing and the remaining money is 0, that means in the third stage also you have spent nothing. But if the remaining money is 1 and the second stage you have spent 0, that means the remaining one you must have spent in the third stage. Going one step up, if you spend one amount in the x3, the optimal profit is 10. So, what will be your optimal profit at this stage? If you have remaining money 1 and you spend nothing at this particular investment option, it must be 10, because this portion is 0, this portion is 10. So, that gives us 10. So, using that you can fill up all the values. For an investment of 2 it should be 14, for an investment for an investment of 2 it should be 14, for an investment of 3 it should be 18, for an investment of 4 it should be 22, and for an investment of 5 it should be 26. So, that is for the no investment. If you invest 1, what is the return that you are going to get? The return for this investment is 3x2 plus 8, that should be 11, because x2 equal to 1. So, 3x2 plus 8 should be 11. Now, this 11 is this one, because if you spend 1 at the second stage, that means at the third stage you have nothing left, because total fund is 1 you have spent in this stage. For x3 therefore, it should be 0. So, if it is 0, then that earning will be 0. So, that means 11 plus 0, that should be 11 only. Is it all right? What will be the earning if you had a spend of 2? You have 2, you had only 1 you have spent here, that means 1 more is remaining, that is on x3. Go back one slide. For 1 the optimal was 10, that means f3 star s2 minus x2 is 10. So, 11 for 1 and 10 from your next stage, then it should be 21. So, these involved calculation has to be made, and the optimal values that has to be really brought in on these calculations. So, if we write those optimal calculations, you can see that these at x2 equal to 1 stage, the next value should be 25. Why it should be 25? Because at x2 equal to 1 it should be 11, but the remaining 2 will fetch a profit of 14, because f3 star, if we write all these f3 star s2 minus x2 values, then x3 equal to 0, it should be 0. So, equal to 1 it is 10, equal to 2 it is 14, equal to 3 it is 18, to 4 it is 22, equal to 5 it is 26. So, these are the values. Look here once again. So, 0, 11, 21, 25. So, that is the stage 2 calculations. So, these are the stage 2 calculations. So, the stage 2 calculations you can therefore obtain all those values based on by making use of the x2 equal to 0 optimality values, and then you can get the 11, 21, 25, 29 and 33. Once again, why 33? Because x2 equal to 1, therefore, it should be 4. So, 11 plus 22, that is 33. Similarly, at x2 equal to 2, what will be the optimal values? This one is 14 and 2, so 0, so it should be 14. Next one 14 plus 10, 24. Next one 14 plus 14, 28. Next one is 14 plus 18, 32. So, like this, if you complete this chart and then you see row wise what are some optimal values. So, clearly speaking, if you see these row wise, the optimal value is 0. If you see this row wise, the optimal value is 11. If you see this way, optimal value is 21. If you see 25, this row 29, this row 33. Now, you may be amazed to see that why all the optimal values are at x 2 equal to 1. There is no pattern in this, incidentally it has happened here. Does not mean it will happen in the next problem also. In fact, we have taken a second problem, it does not happen there. So, there is nothing to think just because here a certain column will become optimal, nothing like this. So, anyhow, if you therefore write the optimal payoffs at this level, then for 0 it is 0 value, for 1 it is 11, for 1 it is 21, I mean for next one the optimal value is 1 and it is 25, next one the optimal value is 1 and it is 29, and the last one the optimal value is 1 and it is 33. So, those are the values of x 2 stars, right, for what is the optimal payoff at this stage that has been given, and what is the corresponding x 2 star which is also noted and that is highlighted in this chart. So, next go to the stage 1. If you now come to stage 1, at stage 1, so you see now the fund available for all 3 investments has to be the entire amount, that is 5. Now, out of this entire amount, that is 5, now obviously you have 6 choices, that is x 1 equal to 0, x 1 equal to 1, x 1 equal to 2, 3, 4 and 5. And at the stage 2 funds are all written here, right. Stage 2, just previous slide, if you see, these are our optimal values 0, 11, 21, 25, 29 and 33. So, same values are written here. So, these are the funds for stage 2, the optimal values of stage 2, they are all written here. So, supposing you have total fund available at stage 1 5 and you spend nothing at this stage, that means what? That means that remaining, that means the entire 5 you have spent in the remaining stages. If you spend the entire amounts 5 at the remaining stages, then you are going to get an optimal profit of 33. Out of that you have spent 1 in x 2 and obviously remaining 4 in the x 3. So, anyhow those are different, but you have 33. So, that means with x 1 0 you get a 0 profit, because if you invest nothing you get nothing from that, but 33 from the remaining amount. So, total profit in this case would become 33. What would be happening if you are spending only 1 at first stage? That means 1 at x 1, 4 at the previous, 4 optimal value is 29. So, 29 and 10 39. What will be at the next? 17, because if x 1 equal to 2, these will become 17 and this one will then become your 17 plus 25 equal to 42. Why 25? Because 2 here, remaining 3 at the stage 2. Then if you spend 3, then the remaining 2 you spend here, that is the stage 2 where the optimal was 21. So, net total is 45 and finally, 4 and 5 the values are 42 and 38 respectively by similar method of calculation. So, now if you look at which one is the optimal at this level, then we see that x 1 is the optimal value. Is it all right? So, look here how Bellman's principle is working, that irrespective of how you have got optimal value at this stage, the remaining distances must constitute an optimal path. So, remaining distances are at this stage, that is constituting an optimal path. So, the total optimal therefore should be 45. That means, that is the maximum that we can achieve. Is it okay? So, we achieve a maximum of 45. and this has been illustrated further. So, this is the chart once again, that whatever calculations we have done. So, what becomes our optimal solution? The optimal solutions will be x 1 should be equal to 3, x 2 should be equal to 1, and the remaining one should go to x 3. So, that means you should spend, because dig further into these two. Let us go back and see how these two has been obtained. See this 2, that is this 21, if you see further, then x 2 equal to 1, and the total money was 2. That means 1 was from the previous stage. That means at stage 3 that 1 has gave us 10, at stage 2 another one would have given 11 plus 10 21, and in the final stage 3 the remaining 3 would have given us 24, and the whole total we got is 45, right. So, that is our optimal solution for this problem, x 1 star equal to 3, x 2 star equal to 1, and x 3 star equal to 1, and therefore, the total payoff will be 45, and this 45 payoff is shown, look here in this diagram how this has happened. So, that means from stage, see if we come from backward, from stage 1 we have invested 1 here, we got a return of 10, we invested another 1 here, we got a return of 11, and then we invested how much 24 here, I mean invested 3 here and got a return of 24. So, 24, 11, 10, 45, that is our total payoff, and we found this path by really evaluating some of these paths and not all the paths. That is where the advantage of this particular dynamic programming method. So, having understood that how this problem is, sometimes what happens if you do only one problem, the understanding may become incomplete. So, let us take one more problem of similar type, let us call it a project allocation problem. So, let us say company has 3 lakhs to invest in multiples of rupees 1 lakh in 3 projects, and if xj rupees are invested in project j, and the return therefore is Vj xj, which are given in this manner. So, if you invest 0, 1, 2 or 3 for project 1, your profits are 0, 45, 70 and 90, project 2 0, 20, 45 and 75, and project 3 0, 50, 70 and 80. Is it all right? So, how should the company invest rupees 3 lakhs in order to maximize the net present value obtained from the investments? So, let us look at how do we go ahead with the problem. So, at the very first, again we can take, there are 3 stages, there are 3 different projects. So, each investment takes place in a stage, right, and there are 3 stages. What should be the states? The amount of fund available for rest of the projects. So, for stage 1 entire 3 lakhs, for stage 2 and stage 3 there are 4 states, anything between 0 to 3 lakhs in steps of 1 lakh in the second and third project. So, what are some decisions? Decisions would be the amount that you invest, these 3 lakhs, how you invest. So, obviously, at stage 1, stage 2 and stage 3, at each stage you have up to 4 options 0 to 3 L in steps of 1 lakh. These are the decision options at a given this thing. So, this means one can invest between 0 to 3 lakhs in steps of 1 lakh in any combination in the 3 projects, provided money exists. Now, this is our graphical representation. So, once again if you look that from stage 1, if you can see those returns and you can combine them here. If you invest nothing at the first stage, your return is 0. If you invest 1, your return is 45, invest 2, your return is 70, invest 3, your return is 90. Now, depending on what you invest, you can reach one of those 4 stages. Again, if you invest nothing, profit is 0, the return is 0, 20, 45 or 75 depending on these values. And at the project third level, If you invest nothing, obviously only the remaining amount can be invested. So, it could be 0, 50, 70 or 80, because here 3 to 0, that means as the state changes from 3 to 0, 3 is the remaining amount. So, you must have invested 3 amount, and for 3 amount the return is 80. So, once again the problem really is find the path here which maximizes our return. So, what is that path which maximizes the return? Obviously, if you this problem is easier. So, if you look a little carefully, can you find what is that path which gives us the maximum possible profit? So, can you see here that if you take here, this is 45, this is 20 and this is 15. So, it is 115. This could be a candidate, or there are different other paths. This one is 80, this one is 90. So, this one is again 90, this one is again 90, this is again 90. So, all these different paths are available. This one is 45 plus 20 plus 50. So, 115. So, all these different paths are available which are candidates. But once again the exhaustive search method requires much more computation. For a simple problem it does not look, but for more complicated problem obviously it will take much more iterations and time. So, once again what is our recursive relationship? The recursive relationship would be depending on the at stage n what happens, and at stage n plus 1 what happens, and what is the contribution of x n, that is V n x n, and the value of f n x n S n x n will be V n x n plus f n star n plus 1 S n minus x n, and the optimal value of that should be the maximum value of this expression given a x n, where S n is the total amount of fund for investment, f n star x n is the optimal payoff at stage n, V n x n is the immediate payoff from the current investment, and f n star n plus 1 S n minus x n is the optimal payoff at the previous stage. So, I hope by this time you are able to understand the recursive relationship idea, and but please remember these recursive relationships are problem dependent. For another problem the recursive relationship will be different. So, how your stages and the states are combined, how you have really computing for a given problem based on which the recursive relationship will depend. For investment problems of this type, this structure is there, right, but this structure may not be valid for another problem. So, we must know that how much of it is generalized and how much of it is not. So, having known that, let us see what we do at the stage 3 calculations. See, at stage 3 values, once again let us see for project 3, we have the 0, 1, 2, 3 and the returns are 0, 50, 70 and 80. So, look here, same 0, 50, 70 and 80 returns are put here. At stage 3, if you have 0 amount available, obviously you can invest 0 and your return will be 0. If you have 1 available, you can either invest 0 or 1, depending on what you invest, you get either 0 or 50 return. At 2, you can invest 0, 1 or 2 and get 0, 50 or 70 return, and if you have 3, then 0, 50, 70 or 80. Now, what are some optimal values? 0, 1, 2, 3 and 0, 50, 70 and 80. Those are our optimal values. So, having these optimal values, now the next one is can be therefore computed. So, what is there? Now, already we know that the some of the optimal values are here, that is 0, 1, 2, 3 and 0, 50, 70 and 80. Fortunately for us, this x 3 star, f 3 star, these values are 0, 50, 70 and 80 for x 3 equal to 0, x 3 equal to 1, x 3 equal to 2 and x 3 equal to 3. For different values, these are the optimum values. So, what we do, if it is 0, obviously for the second fund, the second fund calculation, second fund calculation, obviously the formula, let us see the formula, these returns are 0, 20, 45 and 75. So, 0, 20, 45 and 75. So, if these are the values, then you see if you have invested nothing, then the same 0, 50, 70, 80 which are optimal for the third stage, they will be put here. But if you put 1, then you get 20 and 0 from the third stage. If you give 1 and the total fund available is 2, then 1 you invest in the third stage and you get 50, so 70. So, like this, if you 1 and 2, then you get 90. What is that 90? 20 plus 70, that is 90. By these we make the calculations, and this time you see the optimal values are different. Optimal values, if x 2 equal to 0, optimal value is 0. If x 2 is the optimal values are the if you have 1 available, 0 available, the optimal is x 2 star 0, return is 0. If you have 1 available, then optimal is do not invest anything, put that 1 for the third stage and get a profit of 50. If you get 2, then either invest 0 or 1, you get a return of 70. If you put 3, I mean total is 3, then you invest 2 and 1 you invest at the third stage and get a total optimal payoff of 95. That is the stage 2 calculations. And that stage 2 calculations, when you combine to the stage 1 calculations based on the appropriate values, which are again the calculations they are available for stage 1, then you get 95, 115, 120 and 90, right. So, that 120, although we saw 115, but there really there is an 120 also. So, that 120 is the optimal profit, right, and these 120 will be invested in this way, x 1 star is equal to 2, x 2 star equal to 0 and x 3 star should be equal to 1. And look how this is shown here, this is shown in this one, that is from 3 to 2 you invest at the stage 1, invest nothing at the stage 2, invest the remaining 2 at the stage 3. So, here you get a profit of 70, here you get nothing and here get 50. So, you get a total profit of 120, which is our optimal solution, right. So, we have done what is known as the investment problems and a kind of problem, that is project allocation problem for dynamic programming, and we have seen how through a recursive relationship we can apply dynamic programming and solve such problems, right. So, in our next lecture we shall see more such problems.